Welcome to another week here, talking about circuit layout. So we're now going to start looking at footprints. So I'm going to go into Cadence here, and you'll notice on mine I have actually a couple versions of Cadence. That's because I'm testing a newer version, and because we're using a 2016 version, you might say, hey, it's 5 years old, that seems kind of outdated, but companies actually don't update as quickly as you might think because it's expensive, number one. But I'm currently concluding my testing on the 17.4 version, which will probably be installed soon on our computers. But they don't really look that much difference. They have a slightly different background look. I'm going to go ahead and get the footprint editor. Now we have this capture. Now, technically, yours might look different. It might be under Allegro as opposed to how mine here is just all things are listed under here. You might have under Cadence, you might have Allegro directory listed. But basically, we're looking for the PCB editor. And you can even say it's Allegro that's being launched here. And if it says something besides Allegro, as long as it's the PCB editor, that's what's the issue. Now, yours will probably have something on it, or if you're using the web version, it'll probably be blank. Whether it has something on there or not is kind of irrelevant at this point. I will just go ahead and show you that if I zoom in here, this is actually a part that I worked on for another long time ago, and these white dots are actually like little grid points here. So there's ways to draw these things by hand, and then there's also ways to do some things with command lines. But initially this week, we're not going to even worry about how to draw these components by hand. We are going to simply do using the wizards. And so I will go ahead and show what we're going to be doing here is we'll be doing kind of these package symbol wizards. And then there's also package symbol. So I'm just going to show you, I'm not really going to save this part. I'll just do test here just to show you the entry of the package symbol wizard. So the package symbol wizard is sometimes helpful and sometimes not. It really depends on the company you work for on whether or not they would want to use something like this. The idea behind this is to provide a quick way for creating footprints for some very common package types. And so, for instance, dual inline package, small outline integrated circuit is SOIC, and then there's TH as through-hole discrete component, SMD is surface mount device discrete, so that'd be like a resistor, capacitor, inductor, things like that. There's something that's called a ZIP, and then there's a SIP, single inline package. There's also PLC, QFPs, ball grid arrays, BGA. So there's lots of different types of them. And, based off the CAD diagram, we can maybe determine whether or not one of these wizards is going to be helpful to us. And so let's just go ahead and take a look at one of these wizards. And this is going to be a pretty short one here. Now, in order to use this here, and we'll go through this again here, is we have to send in a template here, and it has to do because it sets up the default parameters. And so if we use the default Cadence supplied template, which is what we're going to use, we hit load. Now it's going to say, give you a warning here or something. Always click yes to proceed. That's actually because an update hadn't been installed, but it's fine. We can ignore that. Now, if you work for a company and you're using this, most likely they'll have a custom template that sets up. Because you can see when I loaded the default template, all these white dots appeared because it set up the grid spacing and everything else like that. Then again, we'll have option of units. Default is mils. So we have to keep that very careful in between which ones we're doing. There's a reference designator, which we'll talk about in a second. And then you can see this is where the wizard part is going to get us in here. Um, First off, it reminds us if the units were in mils and says, okay, number of pins, and then you have to enter these dimensions. And of course, what's nice is it literally just puts this information right here on this so that we can see what those dimensions are in reference to. So hitting next again says doing a default pad stack for symbol 1. I'm just going to use some of the ones that are not really standard naming convention. Let's just do that one. And then we'll talk a little bit about that again. And then we hit the finish button and it creates a footprint for us. And we'll be able to see what all these different colors mean here. And one of the things you can see as far as what these different colors mean, if I go here and look at the active subclass, there's all sorts of different, these are all actually different layers, believe it or not. There's all sorts of things here. So like there's board geometry, but that's not really, we're not talking about the board, but package geometry. Okay, well there's assembly top, bottom, there's pin number, which is yellow. Okay, so that's what those numbers are. It's numbering the pin. There's a silk screen layer, which we'll talk about a little bit more. And so that's kind of labeled in this little color here. Solder mask top and solder mask bottom, paste mask and everything. Now, some of these are the same color, and yours might have a different color scheme. You can actually go in here, click on these little color 192 things here, and change the colors for the different values here. And whatever company you work for probably has a default set of colors that they use for the different layers. But we will talk about those layers in more detail. So that's all I really wanted to talk about in this video, is just to give you an overview of what it is we're going to be diving into. And in fact, we're going to start the next video with actually diving into creating a package or a footprint for one of the components we were even looking at last week.